Welcome, my friends, to the Pus That Never Ends, another Puscast. This one is covering the last 2 weeks of January 2012. We have a mere, 11 months before the end of the world. This is, of course, brought to you by Pusware, LLC, where you can find the Persiflager's Infectious Disease Compendium. It's an online reference. It's an iPhone, iPad app. It's all the wisdom of 21 years of infectious diseases distilled into 600 plus pages of ranting. What more do you really need? Well, I'll tell you what you need, as long as I'm plugging myself. There's a sale going on right now at Amazon. The Pus Whisperer, my first year's collections of blogs with all new typographical errors, is on sale for 99 cents. Yes, only 99 cents, and will be on sale for 99 cents until the temperature in Portland, Oregon hits 99 degrees. I have yet to decide if that's going to be Fahrenheit or centigrade. Otherwise, the rest of my multimedia empire can be found at moremark.squarespace.com. The references are available online. This is no longer a CME accredited podcast because doing CME became a pain in the neck. Otherwise, we will move on to what I think will be a short Puscast this month because there just isn't a lot of literature out there that I thought was of interest. Or I should say that I didn't think was of clinical relevance. So let's get on with the literature, shall we? Congenital cytomegalovirus is a nasty disease, and one of the sources of CMV, actually the major source of CMV, is other human beings. It's spread person to person. Can it be spread from environmental exposures? Well, perhaps. Kids are filled with spit, and to have children is to know that they wallow in the bodily fluids of themselves and others. So they took a culture specimen of CMV, they grew it up, and they suspended it in, get this, filtered human saliva. I wonder who was the donor of that. But then they took this spit and CMV concoction and smeared it on various and sundry environmental surfaces and found that CMV was viable on metal and wood for an hour, glass and plastic for 3 hours, and rubber, cloth, and a cracker for 6 hours. It could be cultured off of wet surfaces, but not as likely dry surfaces. So the importance here is that if you have children and you're pregnant, and there's saliva all over the place, you should probably wash your hands well after cleaning up said spit. Still, if you have a kid at home, you're probably going to wallow in the kid's bodily fluids no matter what you do, kids being covered with a less than thin veneer of their own goop. But still, it is interesting to know that you can get CMV in the environment for prolonged periods of time and could be a potential source for infection. I usually do not talk about animal models in this Puscast, mostly because you always wonder about the relevance in human beings. Humans are, of course, not mice. But there's a pair of interesting Journal of Infectious Disease articles concerning obese mice. These are mice that are either genetically obese or are force-fed till they become Americans. And two interesting things in terms of these obese mouse models. One is that mice with diet-induced obesity do not respond well to the H1N1 vaccine compared to non-fat mice. The other is that mice who have obesity and are given influenza have more severe disease, have higher mortality rates, and their lung does not respond with repair mechanisms as well after influenza compared to normal mice. Interestingly, oseltamivir is protective for mortality in this model. The H1N1 outbreak disproportionately affected the obese in terms of morbidity and mortality, and there have been studies, if I remember right, to show that the obese do not respond to the vaccine as well. And this is all confirmed in the mouse model. Interestingly, and this was in a JAMA editorial a while back, being obese is a pro-inflammatory state. And if you are in an inflammatory state, you will be less likely to respond to a antigen, and you're more likely to overreact should you be exposed to the real deal, i.e. an infection. So I think this is an interesting mouse model that correlates very well with human disease with H1N1 and all the morbidity and mortality that we saw in the obese patient. I am not usually involved in the treatment of hepatitis C. In my institutions, for historical reasons, it's been a GI illness. So I mentioned this study about hepatitis C in passing. It was in the New England Journal of Medicine, and they looked at hepatitis C genotype 1s who had not responded to standard PEG interferon and ribavirin. And they were randomized, and this was very small numbers of patients, to get some new antiviral medications, specifically daclasvir, DACLATASVIR, or asumprenavir, ASUNAPREVIR, and found good effects in both patients when combined with PEG interferon and ribavirin. Genotype 1 hepatitis C has not responded well to standard therapy, so it is nice that there are new agents coming down the pike for the treatment of more recalcitrant strains of hepatitis C. I'm sure in 2020, when and if I need to redo my boards, hopefully I'll be retired before 2020, I will miss all the hepatitis C questions. A pair of HIV studies that probably just warrant a quick mention. One is that if you have chronic hepatitis B and you get HIV, your morbidity and mortality are double those of non-HIV patients. So having hepatitis B negatively affects the outcomes in HIV patients. The other was an article that looked at HIV transmission. Now, you may or may not know that after binding to the CD4 receptor, HIV then either binds to the CCR5 or the CXCR4 receptor and then is taken into the cell where it does its dirty deeds. If patients are CXCR4 positive, or I should say if the virus is, you tend to have a faster progression of disease and lower CD4 counts. This study was confirmed in a recent study out of Luxembourg, where patients who had CXCR4 at the time of diagnosis tended to have lower baseline CD4 counts, although it was not associated with increase in transmission, even though there's been some suggestion that those patients might be, in fact, more infectious. It did not correlate with viral load, but it's more data to suggest that depending on what the type of HIV you have, be it CCR5, CXCR4, or dual tropism, you may have more advanced disease, and perhaps you should look at blocking that receptor earlier in patients who have the appropriate receptor to help both the progression of the disease and to decrease perhaps the spread of the disease. Infectious diseases is nothing if not applied evolution, and I always love articles on this topic. This one looks at the effect of evolution on the virulence, as it were, of HPV, human papillomavirus. They hypothesize that HPV can be divided into high-risk and low-risk types for cancer. Low-risk strains of HPV tend to have higher initial viral loads and rely upon frequent sexual activity for spread. High-risk forms of HPV tend to have lower amounts of viral reproduction, are cleared slower, and tend to rely on more frequent sex for spread. So the sexual habits of the population, whether there's frequent sex or infrequent sex, will help select for the strains of HPV in the environment. This is somewhat confirmed in bonobos, since bonobos use sex for social purposes as well as reproduction and tend to have multiple partners. Because of this, they tend to have low-risk types of HPV and less diversity in their HPV types. So it's interesting how the virus has to, quote, choose, unquote, between producing high numbers of viral particles but being cleared more quickly and relying upon frequent sexual contacts versus making low numbers of organisms so it's not being cleared but relying on infrequent sexual contacts for spread. This is my own conclusion, but given that HPV does evolve very slowly and that there are both a wide number of low-risk and high-risk strains in the human population that have evolved from a common ancestor, it suggests, like so many infectious diseases, that human monogamy has been a big myth, except, of course, for infectious disease doctors. I know a lot of you out there are not routinely treating brucellosis, at least if you're practicing in the United States. This study was out of Macedonia, and they compared doxycycline rifampin for 45 days versus doxycycline rifampin plus 7 to 10 days of gentamicin. And they found that the triple drug therapy had a smaller relapse rate than the double drug therapy. Brucella has always been a difficult organism to treat because it's intracellular, but you had a markedly better response rate to doxy-rifampin and gent compared to double therapy. There is brucella in the United States, primarily in wild swine, which are primarily in the American South. So we are not brucella-free. We are just brucella-free mostly in our domesticated animals. In Portland, the only wild swine can be found at some of the local bars. There are, as you may or may not know, two kinds of tularemia. The one found in my part of the world you usually get from inhaling pureed animals. I had a guy who got pulmonary tularemia from his mowing of the lawn. I assume he aerosolized bunny rabbits and sucked it in. But usually in the Northwest, it's associated with the skinning of bunny rabbits and squirrels and the like. The rest of the world has Francisella tularensis subspecies holarctica, and there's been suggestion that this is spread by bugs. This study looked at the prevalence of tularemia and found it correlated with the number of mosquitoes in the environment. So it suggests that there's the potential for mosquito-borne spread of tularemia, at least in places where you have Francisella subspecies holarctica. That in and of itself is not proof of mosquito-borne spread of tularemia, and there may be other factors associated with it, but still is an intriguing finding. Yet another study to show the benefit of macrolides. The guidelines for the treatment of community-acquired pneumonia say either a beta-lactam and a quinolone or a respiratory quinolone. I hate saying fluoroquinolone. It's an extra syllable you don't need. Quinolone. Anyway, they looked at the outcomes in almost 3,000 patients who were hospitalized with community-acquired pneumonia. Them what got a beta-lactam and a macrolide had a 0.2% mortality rate. Them what got a quinolone had a 3% mortality rate. That's quite a difference. Macrolides are the way to go if you're treating community-acquired pneumonia. That being said, the other benefit in a study out this month showed that if you decrease quinolone resistance in your hospital, not only will you decrease quinolone-resistant pseudomonads, but you will also decrease your MRSA in your environment. Quinolones are evil. They breed resistance, they breed C. diff, and avoiding their use in your hospital is important for keeping numerous resistant infections at bay. I'm sure if you're like me, you've spent significant time on the guidelines to meet requirements for the treatment of community-acquired pneumonia, making sure, for example, that they had assessment of oxygenation, that blood cultures were done before antibiotics, that there was rapid initiation, less than 4 hours, of antibiotics, and the appropriate selection of antibiotics. Interestingly, that none of these made any difference in mortality in patients, whether you met individual processes or whether you got all your processes. The indicators that we have struggled so hard to implement in our, at least in this evaluation of over 2,000 patients with community-acquired pneumonia, made no difference. I think that's interesting. So often these guidelines come out of what you're supposed to do without any supporting data, and it turns out they make no difference, either singularly or cumulatively. Although I would argue that picking the right antibiotics, i.e. a beta-lactam and a macrolide, which is appropriate, is better than picking a quinolone, which is appropriate. So much of the guidelines that we have to meet by the regulatory agencies seem to be, as Shakespeare said, all sound and fury, signifying nothing. They are indeed the tale told by a madman. The term post hoc is Latin for after-the-fact analyses that probably don't mean shit. I say that because a classic post hoc analysis, to my mind, was Zygris study that showed that it was effective in patients with high Apache scores. Then $1 billion was spent on Zygris. Then a prospective trial was done, and in fact, it wasn't the case, and we no longer have Zygris. You can't trust post hoc studies because post hoc analyses often fail to deal with biases that are naturally found in studies. So with that as a background, there was a study in CID that was a post hoc analysis of prospective cohorts that looked at the treatment of ESBL-producing E. coli. Patients either got pip/tazo or a carbapenem, and those who got pip/tazo did better as long as the MIC was less than 2. That being said, it was a suggestion that those who got the carbapenem were sicker than those who did not. It's intriguing that you can use a beta-lactamase inhibitor combination and perhaps get better outcomes compared to a carbapenem with ESBL-producing E. coli. Part of the problem with applying this is you need to know if in your environment the beta-lactamases being produced are appropriate for inhibition by your beta-lactamase inhibitor combinations, and you also need to know the MIC of your organism is less than 2. That being said, if I see the word post hoc in a clinical trial, I think, yeah, right. And we'll see if there's sometime a prospective randomized controlled trial that would help confound the biases naturally found in all post hoc analyses. The data has long suggested that treating patients with E. coli OH157 is associated with increased risk of hemolytic uremic syndrome. This was a study that indeed looked at an age-matched case comparison study of patients who got O157 infections and were treated with antibiotics. Even after they adjusted as best they could for severity of illness, they found that the receipt of antibiotics, in particular beta-lactams, in the first 3 days was a significant risk for the development of hemolytic uremic syndrome. So we can only grow, it's estimated, perhaps 5% of the bacteria that are found in and on us. So it's pretty depressing how many bacteria we have in and on us. You think you're pretty smart, but I've said many times, you're just sentient transport media for bacteria. This study did the 16S ribosome DNA on brain abscesses, and they found far more bacteria there than you could culture. They found 80 different bacterial species, including 44 that had never been seen before and 22 that were unable to be cultured. These were often anaerobes, and the take-home message for this particular study is that brain abscesses, and probably intra-abdominal abscesses too, I would wager, have a complex microbiology, and you can only grow a small number of them. The nice thing is the things you can't grow are usually killed with flagell. So I usually treat my brain abscesses and my gut abscesses with something plus metronidazole. Of course, it's an interesting question how much these ungrowable organisms add to the pathogenicity of brain abscesses and how important they are, but it's probably worth killing them. I wouldn't want to have bacteria multiplying in my brain. It would, however, keep the spirochetes company. The same thing, by the way, applies to the bladder of women. If you test voided and cath urines with 16S ribosome technology, you will find bacteria that cannot be cultured, not infrequently. However, these are probably asymptomatic commensals and not pathogens. Although what makes a pathogen is an interesting question. It's probably less the bacteria and more the host. TB is far more complicated than you would like it to admit. Molecular analyses suggest there are 2 lineages of Mycobacterium africanum, which is part of the MTB complex, and 4 lineages of Mycobacterium tuberculosis. And these lineages are found in different parts of the world. Different lineages are more likely to have different clinical manifestations. For example, some lineages are almost always found to be extrapulmonary, Other lineages are almost always found to be pulmonary. For example, and I'll quote here from the abstract, the percentage of tuberculosis cases that were exclusively extrapulmonary differed by lineage. East Asian 13%, Euro-American 13.8%, Indo-Oceanic 22.6%, and East African Indian 34.3%. So the clinical manifestations of MTB depend in part by what lineage of tuberculosis you have, not something that can be done clinically currently, unfortunately, but you might get a hint by the patient's origin, where they're from, to know which strain of tuberculosis they're likely to have. I had never heard of nodding syndrome before, at least not outside of medical school lectures. There is an outbreak of nodding syndrome currently in South Sudan, and it's also been seen in Uganda and Tanzania. What is nodding syndrome? It affects children. They get perpetual motion head nodding, which unfortunately makes it difficult for them to eat and drink. And they have seizures, non-responsive staring spells, and occasionally seizures. They do not know its etiology or why it occurs, but it has been linked to onchocerciasis, the cause of river blindness. They think currently that the treatment is both anti-epileptic medications and ivermectin, but it's a permanent and somewhat awful disease in that part of the world. I'm sure nodding syndrome will show up on boards at some point in my future. Let's see if I can remember it. Nodding syndrome. I'll probably forget it by tomorrow. 22 minutes. That is short. But that's all I found for this 2 weeks of January. Sometimes they're long, sometimes they're short. I always try and get this to 30 minutes, so I've been more than successful this week. I will see you in approximately 14 days for another Puscast. Otherwise, the references are available online. This is copyright 2012 under the Creative Commons license. Feel free to support this podcast by going to Amazon and buying my 99-cent book, The Pus Whisperer, A Year in the Life of an Infectious Disease Doctor. Seriously, you can afford $1 and you can read it on any computer that can do a Kindle reader, which is every computer. Otherwise, I will see you next time, and as always, thank you for this most interesting consultation and allowing me to participate in the care of this most difficult and challenging case. I shall continue to follow along with you. Thank you. In dictation. Goodbye.